Now, let's look at t-statistic. We use t-statistic when we don't know the population standard deviation or when the sample size is less than 30. We will use the standard deviation of the sample to estimate the standard deviation of the population if we don't know the population standard deviation. Let's look at this example. We know that the average loggerhead sea turtle weighs 135 kilograms. And we sampled 10 turtles from a particular area and find their average weight is 150 kilograms. And the standard deviation is 40 kilograms. Do the turtles in this area weigh more than the general population or not? And we are asking this question at a statistically significant level. So, is 150 kilograms significantly larger than the average of the population, which is 135 kilograms? And we know the mu of the population is 135 kilograms. That's the population mean. The sample standard deviation is 40 kilograms, and the sample mean is 150 kilograms, and the sample size is 10. Let's again follow the 5 basic steps of hypothesis testing. And the null hypothesis is always there's no difference. So mu equals to 135 kilograms. An alternate hypothesis is mu larger than 135. Here it is one-tailed because in the question we ask if the sample average is greater than the population average. In this case, we do not know the population standard deviation, so we can no longer use z-test. So which test do we use then? In this case, we use t-test. In t-test, we have fewer assumptions or requirements for calculations. And for the data type, it is still interval or ratio. The t-test is used to decide if a sample mean is different from a population mean when the population standard deviation is unknown or sample size is less than 30. And here, because we don't know the population mean, so we substitute with the sample mean, but also by estimating it by multiplying and dividing so that we are avoiding some sample bias. In RStudio, you can write this code to calculate the t-statistic. t.test, parentheses, variable name with mu. And here, the variable name is turtle, and the mu is the population mean equals to 135 kilograms. Now, you can put the numbers into this equation. N equals to 10, which is the sample size, and S is the 40, which is the standard deviation of the sample. And then you get the result of 13.3 for the estimated population standard deviation. And finally, you can calculate the t, which is 150 minus 135 divided by 13.3 equal to 1.13. And the third step is to select a level of significance. Again, we use 0.05. However, now the distribution is not normal distribution. So we need to look up a different table for this critical value. Let us look at this t-table. Since we are looking for if it is greater than 135 kilograms, so it is one-tailed. And use one-tailed, we are looking up along this row. And the df is the degree of freedom, which equals to n minus 1. N is the sample size. and -1 because we are only evaluating one parameters. So we get sample size 10 minus 1 equals to 9, and we get the one-tailed statistic with the alpha level at 0.05. So 1.833 is our critical t-value. And now we are comparing the 1.833, which is a critical value, with the 1.13, our calculated t-test. And the 1.13 is within this range, below 1.83. So we do not reject the null hypothesis. That means there is not sufficient evidence to conclude that the sample of sea turtles weigh significantly more than the general population of sea turtles. So a seemingly significant difference, which is 15 kilograms, is not significant.